Today we've actually already talked about parabolas at one point this year. What kind of equation graphed a parabola? An x squared equation. A quadratic equation gave us a parabola earlier this year. Earlier this year when we talked about parabolas, they all looked like this or like this. Okay. We did not have any earlier this year that looked like this. Because that would not be a what? Function. That would not be a function because it would fail our vertical line test. In this lesson, we will have parabolas that can face up, down, left, or right. So we're not going to be concerned with whether or not it is a function. In Chapter 10, we're going to be talking about conic sections. There are 4 different types of conic sections. And the first one's a parabola. And our conic sections, we are not worried about whether or not they are functions. So today we're going to have parabolas that face up, down, or left or right. Our definition of parabolas here is a line so that every point on it is equidistant. What does equidistant mean? Equal distances from some point that's called a focus and a line called a directrix. So earlier this year when we graphed parabolas, they look something like this. In this lesson, we're going to have a point defined called a focus that will be inside of our parabola. And we are going to have a line that is that same distance away that's going to be called our directrix. The definition of the parabola says that if I pick any point on it, connecting to the focus should be the same length as connecting to the directrix. So obviously this is a pretty poor sketch. But those two lengths should be the same of a parabola. Or if I pick this point over here, the distance should be the same to the focus and to the directrix. And that's the parabola. The focus is right on the line of symmetry.
So when you draw a line, you draw it to the point for the focus, but to the line on the directrix?
Yes, so that it hits at a right angle there. So we're saying shortest distance between that point and the directrix. This chart will be very useful to you. Send in homework, and you do not need to memorize any part of it for the test. What you will need on the test will be provided to you. So our equation can take 2 forms. It can be either x squared equals or y squared equals. And which letter is squared determines which direction it is facing. If x is squared, we're going to have a vertical. So it's either going to be facing up or down. If y is squared, we're going to have a horizontal. So it's either going to be facing left or right. Then we're given where our focus will be and where the directrix will be in terms of a letter P, which is in that form of the equation, in the general form of the equation. So use this chart on your homework. Definitely reference it a lot, but don't worry about memorizing any of it. So in this question, we are asked to identify the focus and the directrix and then to graph. But our equation isn't quite in the correct form yet, because in that chart, the squared thing is alone. Whether it's x squared or y squared, it's alone. So I need to get that y squared alone. How do I do that?
Divide by -6.
Times it by -6.
Multiply by -6, or divide by -1/6. Okay. It's -1/6 times the y squared, so we need to get rid of that -1/6. Either multiplying by the reciprocal or dividing. So that gives us -6x equals y squared. We don't need to solve for y. We need to solve for whatever the letter is squared. So y squared is good. If it was x squared in the problem, we're going to leave it at x squared. So we're not going to take any square roots. We're just going to let squared be squared, but we want to get that alone. So this is now in the form of the chart where it would say y squared equals 4px. So is this going to be a horizontal or a vertical one?
Horizontal.
A horizontal one. When the y is squared, it's in the horizontal column of the chart. Then in that horizontal column of the chart, it tells us where we can find our focus. Where's the focus going to be?
P0.
P0. And the directrix?
X equals -p.
X equals -p. So we're taking those values from that chart there. We are asked to find the focus and the directrix, and to find those, we need to know what the p-value is. So in the general form of the equation, it says we should have 4p times x. In our equation, we have negative 6 times x. So that must mean that 4p is equal to negative 6.
So p is negative 1.5.
So how do I solve for p? Divide by 4, and we do get negative 1.5 or negative 3/2. I don't mind decimals as long as they're clean decimals, so this one would be okay, or you can have it as the fraction. So our focus then is at negative 3/2, 0, and our directrix is at x equals positive 3/2, because the directrix equation says that it's at negative p, and p was already negative, so double negative makes positive. Then we're asked to draw it. So for the drawing, you need to plot your focus and your directrix. So the focus is at back 1.5, up 0, and the directrix is the vertical line that's at forward 1.5. For this lesson, your vertex is always going to be at the origin. So we always know it's going to go through 0, 0 at its vertex. Then to sketch it, it should open up around the focus, not crossing the directrix. Questions? It disappeared, and I don't know if I can get it back. Oh, there it is. Okay. Questions? So that p-value can tell us a couple of things about our graph. First, this one had a negative p-value. What do you think that negative did to this? Made it go to the left as opposed to going to the right. So if you have a negative p-value, you should expect your graph to be facing in a negative direction, either left or down. If we have a positive p-value, it'll be facing right or up. The p-value also affects the width of the graph. Now, we didn't make an XY chart and find some exact points. We just kind of sketched it, which is fine. But you should also know some of your graphs are matching, and this can be helpful to you in matching. The bigger the p-value, the wider the graph is going to be. 1 is considered like a normal or medium width. If that p-value is bigger than 1, so this is like 1.5, this graph should be a little bit more in the wide range, as opposed to if the p-value is smaller than 1, like 1/2, that would be a skinnier graph. Okay. Questions? All right, so this one asks us the same question. What do I need to do first? Get the squared alone. So how do I do that? Multiply by 4/3. So then we look at our chart. This is a y squared one again. So just like last time, this is going to be a horizontal graph. The general form of the horizontal is y squared equals 4px. So whatever the coefficient of x is should be equal to 4p. So 4/3 equals 4p. How do I solve for p? I could divide by 4, but then I would be doing a fraction divided by a number, which is kind of weird. So what else could I do? Multiply by 1/4, and that would work just as well. But it's a little bit easier to simplify on the other side. 1/4 times 4/3 is 1/3. Then we use that p-value, and in the chart, it tells us that our focus should be at p0, And our directrix should be at x equals negative p. Okay, using the horizontal column of the chart. If it was an x squared equation, then we would use the other column of the chart and use the vertical values. So we're asked to identify those. Some of your homework questions just say identify the focus and the directrix. So on those problems at this point you're done. So make sure you read your directions for each type of problem so you don't end up doing more than you have to do. This problem, however, also wants us to draw it. So we're going to label our focus and directrix. They're each 1/3 away. And we know we're going to go through the origin. 1/3 being a small number means that this thing is going to be skinnier. The smaller that p-value, closer to 0, the skinnier it's going to be. And we had a positive p-value, so it's facing in a positive direction. So again, one group of your homework questions just asks you, is it facing right or left, up or down? And that's it. So we can look at the p-value, positive or negative, and look at which letter is squared. So we know a y squared is going to be sideways, positive sideways or negative sideways. X squared will be up or down, positive or negative tells us which one of those it is.
What does the focus point have to do with the width of the parabola?
The focus and the directrix are just part of that definition, that if I pick any point, I should get the same distances there if I would connect it. So it's just part of what defines that shape.
So how did you know it was going to be skinnier?
The closer they are together, that's going to force the graph to be tight in. So the smaller the p-value, the tighter everything's going to have to be together. The last type of question we're going to look at is backwards. Here we have the picture, and we want to come up with the equation. So is this one horizontal or vertical? Vertical, because it's opening down. And in the chart, the vertical equation is x squared equals 4py. So then we have to find our p-value. In that vertical column of the chart, it tells us that our focus is at 0p. And in our picture, we can see our focus is at 0, -3. So p is -3, and we can pop that into the equation. Okay. That's it. Questions? We don't have to do anything for x or for y. We just need to figure out what the p-value is and plug it in. So this one is vertical facing again. So again, it's going to be the x squared equation. But in this picture, we're given the directrix, which in that vertical column, it says the directrix should be at y equals -p. So this line is at y equals -2. So that means that p is 2. So we can pop that in the equation, multiply it by 4. We get x squared is 8y. Questions? All right, that's your homework from 10-2. Again, make sure you read your directions so you do what you have to do and you don't end up doing more than you have to do.